Hello, welcome to Math 151 videos. We are going to talk about lesson 2.7 today and transformations of the graph. I love this lesson. It's super fun to see math functions and their base functions and the symbols and how it visually changes the graph. And we're going to use Desmos a lot. And I think that's what makes it fun is we don't have to spend a lot of time of hand graphing them, but seeing it on Desmos. So make sure you have your Desmos open. And I'm going to share my screen. So here are the notes that I've kind of typed up. You might see more by the time that you print this out. But so in 2.7, we're going to talk about a couple different kinds of transformations. One is going to be a left and right shift. That's called a horizontal shift. And that is when we have a graph and we take inside the function, we add a value to it or subtract a value from it. If you add a value to it, it shifts the graph to the left, which seems weird because adding makes you think it should shift to the graph to the right on the number line. But if you subtract a number from it, it shifts the graph to the right. And that's because you're adding and subtracting before you evaluate the function. Okay, that's the key. Now, if you look down here, in this area right here, you can see that this is going to be an up and down shift. This is a vertical shift. Okay, and that's because you are adding or subtracting that constant value after you've evaluated the function. And so that's going to affect only your y value, the vertical shift. Okay, and then, oh, I've got this. Then we're also going to be vertically stretching or compressing. So this is going to stretch or compress our function. Okay. And by doing that, we're multiplying a constant out in the front side of the function. Notice we've evaluated the function and the constant goes out to the front. And it gets bigger or magnifies the graph if that constant is bigger than 1. If the constant is a fraction decimal between 0 and 1, then it's going to make it and shrink it, and it's going to make it smaller. Okay, we are also going to reflect a graph. And we are going to reflect a graph when we have a negative of the function. So when there's a negative value out in front of the function, the graph is going to reflect over the x-axis. Those are going to be the biggest ones that we are going to see. And let's just get started and check them out. Okay, we're going to look at a few examples from the book. And we are mainly working from pages 175 to 179. So this first problem here says the function g of t is equal to t squared plus 1. So the base function is f of x equals x squared. That's the base function, an x squared function, which always is starting at the origin. But this is going to be plus 1. And so it's after we've done the squaring function. And so it's going to shift vertically 1. So a vertical shift plus 1. That's what C is. Okay. So let's go to Desmos and check this out. So you can see here, we have the graph of x squared. And there are the values. And then if I do y equals x squared plus 1, you can see it's vertically shifted up 1 value. And you can also see that if we were to make a list of the data values, you can see that it's been shifted. So let's look at question number 5 in the book. I'm going to turn these graphs. Question number 5 is an absolute value function, and this is the base function here in blue. And I'm going to type in the function that they have in the book. It's the absolute value of x minus 2. And you can see that even though it says minus 2, is shifted over to the right 2. And that's because now when you put in 2 for x, you have to subtract 2, so then you get back to the base function. So it's saying, what do you have to do to get back to the base function? So the base function is to the left of this green function. It's pretty cool. Okay, let's look at number 13. I'm going to just put these in here. And that was number 5. Okay. So number 13 is the base function is the x squared again. So I'm just going to copy that. Oops. I'm going to turn these off. So the base function is this one up here, this y equals x squared. And then number 13 is y equals, and it's x plus 3 parentheses squared. So you can see that that plus 3 means we're shifting to the left. And then we're going to subtract 1, so we're going to shift down after that. So I don't have the -1, we're up on the axis, and I subtract 1 and we shift down. So on that one, on number 13, I believe I was asking you to explain the shifting. Yeah, I wanted you to explain. So this one we shifted right. And then this one is 13 was shift left, 3, then down 1. Okay, 17 has that absolute value as the base function, but the -4 scales it and reflects it. So this is so cool. The negative is a reflection across the x-axis. It flips over. And then the 4, because it's afterward, it's scaling it bigger. And then scaling up. So the c equals 4 is we're scale up. So let's go to our base function. In the notes we have here. So we're scaling up. It's this one here. It's going to magnify it. And then we are reflecting across the x-axis right here. So let's go to Desmos here. Note. And this is number 17. It's Okay, let's turn this one off, turn that one off. Let's turn the base absolute value function on. So there's our base absolute value function. And then number 17 has a negative, so it flips over, and then a 4. So it makes it tighter and sharper. So I'm going to take away the negative for just a minute so you can see what it's going to do. It magnifies it, it makes it bigger and sharper. And then the negative flips it over. There it is. Cool. Next, I wanted to look at number 27. So number 27, the base graph is this x squared graph, this parabola. And I want to show you two different things when the scaling is on the inside and on the outside. So 27 has y equals 2x, and then it's squaring. The 2 is on the inside. So you can see that it's getting, it's sharper here. Okay, now if I had y equals 2 and then just x squared, it wouldn't be as sharp because the scaling is on the outside. It's after we've taken the x squared. So the green is the sharpest because it's doubling it before it gets squared. Very fun. So let's look at number 33. And I will, there'll be a Desmos link that you can click on to see all these different graphs. And you remember over here, you can turn them on and off by clicking on their graph so that you can see the ones that pair up with the same shape. Okay. So number 33 is in the book here. The base function, they tell us, is this absolute value function. And it says, explain how each graph is transformed from this base function and find a suitable expression out for the function represented by the graph. So let's look at, we'll do 31 first. So 31, it's on the x-axis, so it looks like it's only been shifted to the left 1. And so remember, when we shift it to the left, it's a +1 on the inside. So 31 would be x + 1. And then this is the base graph here on in 33 too. So 33, it's a reflection, so we know it's negative, and it looks like it's been shifted up. So it would be negative on the outside and then a +1 on the outside, a +1 on the outside. So let's just see if we can, so the new one is f of x negative, oops, negative, and then absolute value of x, and then a +1. Let's type that into Desmos and see if we did it correctly. So that's the great thing about Desmos is you can always go back and check your work. Just, try what you think is correct and then check it out. And I'm just going to copy that. And we think it's negative and a +1. And I'm going to go up here and turn off this other one's on here. So yep, that's what that looked like. So we did it correctly. Cool. And then we are going to look at number 41 in the book. So 41 says the graph of the function. Okay, they want us to use the verbal description to find an algebraic expression for the function. So the graph of the function g of t is formed by vertically scaling the base graph of t squared by a factor of a -3 and moving to the right by 1 unit. So we want to scale it by a factor of a -3, vertically scaling. Okay, so vertically scaling. So let's see, they want to vertically scale f of t by, what was it, a -3 and to the right 1. Okay. So the new function, we'll call it g of t. So -3, because the vertical is on the outside. And I just want to refer you to the right page. The vertical scaling is, this is a stretch, and it's on page 169. So page 169, this is a vertical stretch. That's the 3. Now the negative means it's reflected. They didn't say that, but they're insinuating it because it's a negative. And then they wanted to shift to the right 1. So actually this has to be a -3 and then -1 squared, because remember, left and right has to be inside the function. So let's go check this out and see if it's doing what we think it should be doing. So I'm going to turn off my base unit here. So my base unit is x squared, okay? And then I'm going to do -3x squared. So that reflected it. I'm going to take off the negative for a minute. And yep, so it made it skinnier. That's what we thought. And then a negative reflects it. And now if I added 1 here, it's just going to move it up. But they wanted us to put it in parentheses. So there we go, shifted right. So wow, a lot going on. We reflected, we scaled, and we shifted to the right. And that is note number 41. Oh, very cool. Okay. The next one I wanted to look at is number 67. So number 67. Oh, no, we can actually look right in the book. I have the book pulled up right here. Here it is. So number 67. Graph of f of x is the absolute value of x plus 3.5, and g is the absolute value of x plus 3.5. Describe each graph in terms of transformations of the graph h of x, the absolute value of x. Okay. So this one we're actually going to do on paper because it's easier to talk about it that way. So let me get them written down. And our base function is h of x, and it's the absolute value function. And so let's investigate these in Desmos, and then we're going to write down our discussion here. This is number 67. And so we have y equals absolute value of x plus 3.5. Why does it not go inside there? X plus 3.5. And so y equals, so there's our base function in blue, and then there is the first function, the plus 3.5. Remember, inside the function, it's going to shift it left. So that first one is a left 3.5. And then this one, the other one is 3.5 up. So it's a shift up 3.5 from the base. So I hope you've enjoyed all of the fun transformations that we've done in this lesson. If you have any questions, please reach out, and I'm happy to schedule a Zoom session to help you. Catch me back for the last lesson of chapter 2, 2.8.